It has been decided to run an XML reader task that reads XML as a thread. The following code has been provided for the header file. So you're given this code. Rewrite this code so that it uses the recommended approach to threading without adding any extra functions. It is not necessary to include the comments. Cool. So they are saying, here it is. It's supposed to do some XML reading and be used in a thread, but this is not what we want. Fix it. So already from this question, you can see what you're going to do. You're going to make this a key object. You're going to introduce your macro. You're going to make this a slot. Good thing it's already void and your signal is already there. Done. Or if you want, you can also add another signal, void, finished. If you want. There. That's it. So that's why I'm saying it's very straightforward. What you do on your worker class is not going to change. You just have to remember, this is everything I do on a worker class. They may twist the questions, but this is everything, right? I don't know if I've got another question here. Oh, there's another one. Consider the following fragment that defines a class that finds guests within a particular name in a specific queue list. So this search for guest class receives a queue list of guests and a name to search for. And now look at this. This one returns a list of guests and there's a find function. And they say, rewrite this class so that it can be run as a thread using the recommended approach. The guest pointers should be emitted one at a time when they are found. So this question is explicitly saying your class must return the guests as and when they are found. So again, you're going to make exactly the same changes. This becomes a key object. You put your macro here. This remains the same. This is going to become public slots. Then you put your void find function here. So you see, I make it void. Then I introduce my signals. So now I introduce a signal. Maybe I can say void guest found. And this one will send a guest that has been found. In this case, it's a pointer. And I can have another one finished. I've got my two signals and I'm done. So with practice, you start to get the gist of it. That is everything you always do. And now, rewrite the main function so that this new class will be called as a thread. Any signals emitted by it can be handled by a function named void handle found. So now they gave you a function called handle found. And this function is in this class called found. Because you can see, right? Found, handle found. So this is the function you are going to use on your connect. You are not required to handle the thread terminating once it has completed its search. So they are saying, don't worry about the cleanup stuff. You are only required to write the lines that will change if any code is, that will change. Okay, there's a full stop here. If any code is added, indicate at which line the code will be inserted. So you're not writing everything. You're simply saying, so here we go. You've got your guest list here. Assume that past guests contains a list of pointers to guest objects. So they are saying you can assume it has been initialized. So from line 16, what do? You make an instance of your search for guests. And then you make an instance of your thread. Then you move your instance to your thread. Then you connect your started signal to your find function. Then you connect your guest found to your handle found. And then you start your thread. So quickly, I'm simply saying, just for the sake of completion, you're going to have search for guest or guest, I don't know. Cause new search for guests. Sorry, I'm not even looking. So this has been done for you already. So it has been declared for you already. It's not a pointer, SFG. Then from line 17, here's a queue thread. Let's do this without using pointers, right? without using pointers. Q thread, sfg.move to thread. Now remember, your move to thread function expects a pointer or an address, which means you give it, in this case, I'm going to use the address to get the address, because remember, this function takes a pointer or an address. That's why when we were using pointers, we just give it the pointer without doing anything else, right? Yeah. But here we are using non-pointer variables, so I'm simply saying you would give it an ampersand because you want the address of this. That's your move to thread function. Same applies if you do your connect. There are different ways of doing your connect. I used to use the old way. So you can go connect. Now you can go thread. Again, you see I put the ampersand because it should be a pointer. Your signal started, and your slot is in SFG. Again, you see I put the ampersand because it must be a pointer, so I give it the address, and your slot is called find, like that. Then I connect my SFG signal guest found, which is returning a guest pointer, to my class. I don't know if it's a static function or not, but let's just say this, and then let's say slot here. Assuming it's a static function, then I can simply go found handle, is it handle guest or handle found, whatever that function was. Let's move this a little bit to the left, and then I give it my guest pointer there. Then I can go thread.start. Cool. So that's how you would. So I've just, instead of using pointers, I'm just using normal variables. And here you can see I'm using this. And there are different ways of doing the connect statement. You can use the most recent way of doing it or the good old way of doing it. It works, right? So that is how you would do. So at the end of the day, what I'm simply saying is, once you know how to set up your worker class and you know how to set up your client, then you are done with your threads. Okay, so more questions that you can go and practice and practice and practice. I think on the theoretical side of things, I've given you the answers. It's all part of the textbook, like Q-thread provides one approach to concurrency. In which situations are threads useful, and when do their overheads outweigh their potential benefits? So this is simply saying, if you look at the example that I gave you initially, right? Your threads will reduce the time it takes to execute something because you are running multiple processes at the same time. So hence, if we look at the example to look for primary prime numbers, we see that it can reduce it maybe by 3 times or so, right? Assuming that it takes 1 second to find the prime number. So that is fine, as long as whatever we are doing is stuff that is computational, like stuff that you calculate, right? But if what you're doing is depending on an external process, like reading a file, it doesn't matter how many threads you spin, right? Because reading a file is going to take it's dependent on how fast or how slow it is to read that file from the hard drive. So that is what this is saying. As long as there's dependency on something external, you may not get benefits from using threads, right? So sometimes the complexity added to software from using threads can outweigh the performance benefits. If a program is bound by I/O input-output, chances are that distributing the CPU's work across multiple threads will not show noticeable improvement in the program's overall performance. If, however, there is a significant amount of advanced calculation that can be done and you have idle cores, threads can improve performance. So if your program is bound or is dependent on an external process or an I/O process, you may not see any significant improvements. Okay, cool.